All right, today we are talking about lenses. More specifically, we're going to be talking about f-numbers. What are they? How do we get them? And why are they so important? The reason I'm doing this little series on cameras and lenses and the technical aspects behind them and what makes them work is because cameras are incredible. And for me, understanding how my camera works helps me use it better. Cameras are tools. And for me, when I understand the tool and I understand how to use it, it helps make me a better photographer. Granted, that might not be true for you. That's not necessarily true for everyone, but for me, I love understanding how my camera works. So this is starting a small series just going over some of the incredible technology that goes into cameras. Today, we're talking about f-numbers. In a couple of future videos, we're going to be talking about specifically mirrorless cameras and why they have such an advantage over DSLR cameras that have a mirror box. Just some incredible science behind it to help you understand your cameras and lenses better and break down some of the beautiful technology that has come out with cameras in the last couple of years. Anyways, okay, now on to the fun stuff. If you don't like math, I hope this video helps you like math. I've got my calculator. I've got this tool to draw circles. Let's get into it. All right, if you go to the Wikipedia page for f-number, it will tell you that the f-number is the focal length divided by the diameter of the entrance pupil. And the entrance pupil we're talking about is inside of your lens here. It's basically, if you look down the barrel, it's the diameter of that opening. While this is true, it doesn't really tell us very much. Telling us that it's the focal length over the diameter of the entrance pupil can help us understand some things. Like, for example, for this 85mm lens, that would tell us to have an f-number of 1. The diameter of the entrance pupil would also have to be 85mm. That gives us some context as to why it's hard to make fast lenses, because the faster you get, the bigger the diameter of that entrance pupil has to get. And of course, on something like an 85 or a 200 or a 400, getting the diameter of that entrance pupil up to 400mm, a little bit challenging. But again, just saying that the f-number is the focal length over the diameter of the entrance pupil doesn't really tell us anything about what the f-number is. How do we get it? Why does it exist? Because the truth is, f-numbers are not specific to photography. You can see them all over mathematics and sciences, and you're about to understand why. So pull out your paper and a pencil and a calculator and something to maybe draw circles. We're going to draw some circles. Okay, let's start with a circle that has an area of 1. Doesn't matter what the units are, it's just going to be 1. It could be inches, it could be square millimeters, could be square parsecs. Doesn't really matter. Surface area of 1. I promise, even if you don't like math, you're going to find this interesting. All the numbers are on the screen. You don't have to do any calculations. So the surface area of a circle is defined as pi times the radius of that circle squared. So for a circle with a surface area of 1, we have that pi times the radius squared is equal to 1. Doing some algebra, we find out that the radius of the circle is the square root of 1 over pi, or 0.56419. To get the diameter of the circle, we just multiply by 2, because the diameter of a circle is twice the radius, so we get the diameter is 1.12838. If you look at that number, it's not an aperture number. It's not any of the numbers we're familiar with. Hang in there, we'll get there in a second. Okay, let's do another circle, but we're gonna cut the surface area of this circle in half. So instead of a surface area of 1, we're gonna have a surface area of 1/2. So the area is going to equal 1/2. Again, units don't matter. Okay, so pi times the radius squared is 1/2. So to calculate the radius, we end up getting the square root of 1 over 2 pi is equal to the radius. So we get a radius of 0.398942, and the diameter, again multiplying by 2, is 0.797885. I want to pause here for just a second. So we just cut the surface area of this circle in half. We went from a surface area of 1 to a surface area of 1/2. But if we look at the diameter of the circle with a surface area of 1 is 1.12838. The diameter with a surface area of 1/2 is 0.797885. So we cut the surface area in half, but if we calculate the change in diameter, we only had to decrease the diameter by 29%, so less than a third. Intuition may try and tell you that if you cut the surface area of the circle in half, you also cut the diameter in half, but we see that that's just not true. But why is that important to us? Well, if you take a look at your camera, if you open up the aperture all the way like we have here, if you just assume that this is the circle of surface area 1, right? So to stop down, to make that pupil half the surface area, so letting in half the light, we don't have to decrease the diameter of the entrance pupil by half. We only have to reduce it by 29%. Super important. That's why we can get so many stops in a camera lens. But that's why on fast primes, you can't go all the way to f22 like you can on 2.8 zooms. 2.8 zooms typically you can stop all the way down to f22, whereas on the fast primes like this 1.4, I can only stop down to f16. Anyways, important piece, not where we're trying to get, but fun fact. Okay, let's calculate one more surface area really quick. We're gonna do surface area of a quarter. So a quarter of the surface area of our first circle, okay? Doing the math really quick, we get the radius is equal to the square root of 1/4 pi. There's a pattern here. So we get that the radius is 0.282095, and the diameter of the circle with a surface area of 1/4 is 0.56419. Yes, that is the same as the radius as the first circle. It's just correlation. If you factor out the 4, you basically get 2 times that. So anyways, okay. So now we have the diameter for 3 different circles. The progressive circles have half the surface area of the one before it. What are we going to do with this? Well, just a few more calculations and then you'll see where I'm trying to get. Okay, so let's take the diameter of the first circle and divide it by the diameter of the second circle. D1 over D2 is equal to 1.41421. Recognize that number? 1.4. If you round that off to the first decimal place, you get 1.4, which is an aperture number that we are all familiar with. Okay, let's do another one. Let's do D1 over D3. That's 2. Another aperture number that we're familiar with. I calculated the diameter of a circle that has a surface area of 1/8. It is 0.398942. Let's do one more calculation. D1 over D4 is 2.82843. Round that off, you get 2.8. All right, so why did I torture you with all this math? Well, I wanted to show you how we really get F numbers and what they really are. F numbers are the ratio of the diameters of circles where the surface area of each consecutive circle is reduced by 1/2. Okay, so what does this mean for us as photographers and cinematographers? Well, we're constantly thinking in terms of stops of light, exposure, and for me, understanding how the camera works, how these F numbers work, helps me better understand exposure, helps me better understand how my lens is bringing light into the camera. Is any of this stuff required to be a good photographer or cinematographer? No. Do you have to know this stuff to make good images or capture good scenes? No. Can this be helpful to some people to understand their tools better? Absolutely. For me, I'm a very technical person. I like to get down into the weeds and really figure out what makes things work. So for me, understanding where F numbers come from, what they mean for a lens really helps me understand my tools and how they function so that when I'm in the field, I'm not second guessing things. I understand what's happening. It helps me understand what does it mean that my 50 is a 1.2 and my 85 is a 1.4, and what are the implications on that for the diaphragm and bokeh and exposure and depth of field. All of these things to me are super important, and I hope some of you found these important as well. Okay, I know that was a lot of math, and I'm sorry. I hope you guys found this useful or at least fascinating or entertaining. I think the world of cameras and lenses is just so beautiful. The craftsmanship and the artistry that goes into making lenses, like some of the classic lenses from Zeiss, from Nikon, from Canon, it's just beautiful. I think truly the manufacturing of lenses, I think, could be an art as well. So I hope you got something out of this video. I hope this helps you understand your camera system better, your lenses better, photography better. Hope I didn't scare you off with all the math. I think it's beautiful. So if you found this video helpful, you know what buttons to press. I do a ton more technical stuff like this on my Patreon page. You can check that out at the link below. Tons of behind the scenes stuff there, live Q&As, portfolio reviews, tons of stuff like that. Thanks again for tuning in, and we'll see you next week.